Hello everyone, I am Mary Joy Serrana from BAA 2A. Now, I'm going to report the topic about the continental drift versus plate tectonics theory. Continental drift. Today, most people know that land masses on Earth moved around, but people haven't always believed this. It wasn't until the early 20th century that German scientist Alfred Wegener put forth the idea that the Earth's continents were drifting. He could this movement, continental drift. He was not the first or only person to think this, but was the first to talk about the idea publicly. Wegener came up with this idea because he noticed that the coast of Western Africa and Eastern South America looked like puzzle pieces, which might once fit together and then drifted apart. Looking at all of the contents, he theorized that they had once been joined together as a supercontinent, which was later called Pangaea. Around 225 million years ago, see Figure 4. The name Pangaea comes from the ancient Greek words pan, meaning entire, and Gaia, meaning Earth. Pangaea is not the only supercontinent believed to have extended. Other supercontinents are also believed to have come before Pangaea. The idea of moving land masses seems obvious now, but Wegener's theory of continental drift, as he called it, was not accepted for many years. Why? Well, for me, one thing, Wegener did not have a convincing explanation for the cause of the drifting. He suggested that the continents were moving around due to the Earth's rotation, which later turned out to be wrong. Secondly, he was a meteorologist, someone who studies weather, not a geologist. So, geologists didn't think he knew what he was talking about. Tectonics. The theory of plate tectonics builds on Wegener's theory of continental drift. In the theory of plate tectonics, it is tectonic plates rather than continents which are moving. Tectonic plates are pieces of the lithosphere and crust, which float on the asthenosphere. There are currently 7 plates that make up most of the continents and the Pacific Ocean. They are African plate, Antarctic plate, Eurasian plate, Indo-Australian plate, North American plate, Pacific plate, and South American plate. There are 8 other smaller secondary plates as well as many other microplates which do not make up significant amounts of landmass. Tectonic plates not only move land masses, continental crust, but also ocean's crust. Since the plates are floating on liquid rock, they are constantly moving and bumping against each other. This means that the sizes and positions of these plates change over time. Tectonic plates are able to move because the lithosphere, which makes up the plates, has a higher strength and lower tendency than the underlying asthenosphere. The solid plates about move along on the liquid rock below. You may imagine that these plates are zipping along, but in fact, they are moving very slowly. The speed of the plates ranges from a typical 10 to 40 millimeter year, about as fast as fingernails grow. to as fast as 160 millimeters a year, about as fast as hair grows. Geologists came to accept the theory of plate tectonics in the late 1950s and early 1960s after coming to understand the concept of seafloor spreading. Seafloor spreading occurs on the seafloor where ocean plates are moving away from each other diverging. When this happens, cracks occur in the lithosphere, which allows magma, hot liquid rock, to rise and cool, forming a new seafloor. The opposite of divergence is convergence. This occurs when plates are moving towards each other. Material may push upwards, abduction, forming mountains, or downwards, subduction, into the mantle. The material lost through subduction is roughly balanced by the formation of new ocean crust by seafloor spreading. Volcanic. Volcanic eruption and earthquake can occur, and mountains and ocean trenches can be formed when tectonic plates meet. Let's look at some of these processes in more detail. Mountains and volcanoes. What do mountains and volcanoes have in common? They are both large, steppe landforms made of rock that are formed when tectonic plates are pushed and pulled. Whether you get mountains or volcanoes depends on the type of tectonic plates and where they are colliding. To understand whether you will get mountains or volcanoes, you need to remember two things. There are two major types of tectonic plates, ocean and continental. Ocean plates are denser than continental plates. Let's look at how tectonic plates form mountains or volcanoes. 1. When two oceanic plates diverge, pull apart, undersea volcanoes are formed. Volcanoes are caused by cracks in the earth crust. An example of this is the Mid-Atlantic Ridge, which extends from the Africa Ocean to beyond the southern tip of Africa. There are so many volcanoes in the Mid-Atlantic Ridge, and they are so large that is considered the longest mountain range in the world. Iceland is located on this ridge. The red triangles on the picture where there are active volcanoes. 2. When two continental plates converge on land, collide into each other, mountains are formed. This because both of the plates, which are similarly dense, will push up against each other, causing the rock to get all folded and bunched up. The crust in the region of a mountain is thicker than the surrounding crust. The Himalayan mountains are the result of this type of process. 3. When an oceanic plate converges with a continental plate, the oceanic plate will move under the continental plate. Subduction because it is denser. The ocean plate may go deep enough under the continental plate into the mantle that it melts and forms magma. Increased pressure from beneath the earth and build up and cause the magma to seep up through weak spots in the crust. Magma under higher pressure sometimes comes through volcanic events in the form of flowing lava, forming a volcanic cone.